Alright, so in this video we're going to take a look at what's called a mixture problem. And these ones, let me scooch this down so you can actually see the top part here, are generally easier if we create a little table for them. So mixture problems are a special type of weighted average, and we most often encounter weighted averages actually when we're talking about grades. So in this class, we have a weighted average where homework is worth 65% of our grade, and then tests are worth 35% of the grade. So not everything is worth the same amount. It's not every single assignment that you do, whether it's homework or test, is not worth just 100 points and you get to put in the grade book. It gets into a different category, and it's kind of multiplied by 65%, and you see how much of the 65 points that are available actually is given to you based on the grade. So this is a very simple version of weighted averages, but we use it in this school. And we are using it for not just math class, for every single class. That is our grading policy. So if you didn't know that, now you do. So we're going to use kind of that same idea, but it's a much easier to organize the information in a table. So 100% you need to make a table to help you organize this information. So let's go ahead and read this problem. So we have Laura invested her savings into 2 investment funds. So the $12,000 that she invested in Fund A returned a 2% profit. The amount that she invested in Fund B returned a 5% profit. How much did she invest in Fund B? If both funds together returned a 3% profit. So you can see I've already created a table for you on this one. So for our example, when you do this on your own, you're going to have to create your own table because Alex does not create the table for you. So down the side here, you're going to label it based on, it might say mixture, or in this case it actually gives you a name, Fund A, Fund B, and the next one is going to be adult and child tickets, things like that. So they might give you a name, but really it doesn't necessarily matter what you name it as long as you know which one it is referencing. So Fund A, that had a 2% return, and we know the amount she invested. They told us she invested $12,000 into Fund A. And the profit percentage that she got was 2% for that, which was part of the name that I put on the front too. So when we're going across this table, we're going to multiply the 2, and that's going to equal the profit table. So 12,000 times 2%, that gets us $240. So that's her profit there. And then the amount that she invested in Fund B, well, they didn't tell us the amount, right? But they do tell us that it's 5%, so I know the 5% part. But I don't know how much she invested in Fund B, so I'm just going to call it B. So B times 5%, remember 5% means that I need to move that decimal back 2 times so that I have a decimal. I do not want to write it as 5% in my actual equation here. So I'm going to write it as 0.05 B. Okay, so that's Fund A, that's Fund B, and then we have the total. So it's always going to have this many columns in it. Okay. So the total is a 3% return. So I already know this is going to have a 3% return total for both of them. And then to find out the total amount she invested, well, I'm just going to add together these 2 pieces. She did 12,000 plus whatever she did in Fund B. And then I would still multiply these. Okay? So I'm going to multiply across this way. So this one, don't forget, you're distributing like this, because it's going to be 0.03. We need to make sure we turn that into a decimal. We're going to multiply like this. So we're going to distribute. Okay, so 12,000 times 0.03, that's going to be 360, plus 3% times B, well, that's just going to be 0.03 B. Alright, so now that I have this part set up, I can actually set up an equation, because the 2 added together here should equal the total. The profit from the 2 should equal the total profit. So this is why we want to set up this little table, because it helps us fill it in across. So we go across on each one, and then we go down on the first and the last one. The only one we don't go down when we're adding down is the profit for both. For this one, it's actually a difference of 5 and 2. I think that's more of a coincidence than an actual rule there. So let's go ahead and set up So I go 240 plus 0.05b, and that's going to equal 360 plus 0.03b. Alright, so now we want to start to solve this one like we would any other equation. So I want the two variables to be on the same side. So since I have positive 5 and a positive 3, I'm going to subtract in a way. So I'm going to subtract the 3 over to the left side so that I end up with a positive here. So I have 240. And I can think of this, I know it's 0.05 and 0.03, but 5 minus 3 is 2. And then I can just put the zeros on the front there. And then the b comes down with it. Don't forget that part. I have students forget that part all the time where we all of a sudden don't have a variable because it was kind of left behind. The 360 just comes down because we haven't done anything with it yet. And 0.03 minus 0.03 cancels out. So now I want to continue to try to get this variable by itself. So I'm going to do addition subtraction first. I'm going to subtract the 240 that's being added on the same side as the variable. I'm going to scooch it to the other side here. 240 minus 240 cancels. 0.02b equals 360 minus 240. Let's see, we get 120. So now I'm multiplying by 0.02. I'm going to divide on both sides. Anything divided by itself becomes 1. So b equals, and if you do the division here, so if you're doing the long division on this one, you'd have 120. Let me scooch that over just a little bit. So I'd have 0.02 divided by 120, but we don't really want to do this. What I want to do is go 1, 2. So I would just have 2, and since I moved this one over 2, I have to go 1, 2, and move this one over 2. 1, 2, like that. So now I can divide this. So 2 goes into 12 6 times, and then I'm already at 0, but I have to fill these gaps in. So I'd have 6,000. I 100% believe that Alex will have the calculator open on this one. They do not expect you to do the long division on this one, but you can. You saw it didn't really take me that long to get that division done, especially with the rest of the problem kind of being pretty involved there. Alright, so let's go ahead and take a look at the next piece here. So we have some tickets being sold. So we have at the movie theater, child admission is $5.50 and adult admission is $9.20. On Sunday, is $9.20. On Sunday, 187 tickets were sold for a total sales of $1,354.10. How many child tickets were sold that day? So adult tickets, I know how much they cost. They told me they're $5.50 for adult admission. Sorry, adult admission is $9.20. I'm reading that right. Help if I put it in the right box. Cost is $9.20. And I want to multiply that by the number of adult tickets that they sold. I don't know how many adult tickets they sold, but they must have sold some. So that would equal 920 times A. Child ticket, again, I don't know how many child tickets they sold specifically, but I do know how much it costs. The child tickets are $5.50. So it's going to be $5.50 C. And then the total, so the total number of tickets they sold, well, that would be adult tickets plus the child tickets they sold, right? And so now, let's see, the total cost, let me make sure I'm not messing that up. I don't know if we need a total cost on that. Well, we can do a total cost. It would be these two combined, which would be kind of a little misleading actually, because it would have to be a little separated, but I do know the total profit, 10. Let's see, and oh, you know what? We know what this equals. This equals 187 because they told us that. Okay, so this one is a little different only because we don't necessarily have to have this part filled in because we wouldn't have a total cost for one adult child ticket. They cost different amounts. So for this one, we have two different pieces here. I have the cost, like this. So if I add these two costs together, I'm going to get the amount that they sold, or their total profit anyway, like that. And then I also have another equation here, which is the A plus C equals 187. So that's a separate equation. And what I want to do is use this one, and I'm going to write it kind of off to the side here because I don't want it to be in my way. I'm going to use this one to substitute in. I can't have both A and C. I need to know what one of them is. So since I want to know how many child tickets we bought, I actually want C to be in the equation. So I want to replace A with C. So I want to know, what does A equal? So I'm going to do this. This is going back to literal equations when we're kind of manipulating the equation a little bit. Well, if A equals C minus C cancels, I have 180 minus the child tickets. So now I can take this amount here. I know this equals A, and instead of A here, I'm going to put 187 minus C. So I'm going to have 187 minus C, and the rest of the equation is going to stay exactly the way it is. So this way, now I only have C in the equation, like this. So now I'm going to multiply. I'm going to distribute this $9.20. So $9.20 times 187, that is 1,720.40 minus 920 times negative C is negative 920C plus 550C equals, and I'm just going to kind of do an arrow because I'm running out of room there. Sorry about that. So now I can combine these like terms here. So I'm going to have 1,720.40 minus 920 minus 550 is going to be $3.70 C. So I just combined these two. It was 920 negative plus 550 positive equals, now I can bring this down because I gave myself enough room there, 10. Alright, so we're definitely getting down to the end here. So now I have C all by itself on one side. Well, not all by itself, but I have all the C's on one side. Now I want to get it by itself. So I'm going to subtract the 1,700 from both sides, like this. Whoop. I'm going to have negative 370C, because anything minus itself cancels out. So the 1,700 cancels itself out there, equals the 1,300 minus the 1,700, and I'm rounding that as I'm saying that. I'm just not saying the entire number, is negative $366.30. So my very last step here to find out how many child tickets we sold is to divide by the negative 370, because I'm multiplying here. The opposite of multiplication is division. So anything divided by itself becomes 1. So C equals $366.30 divided by $3.70 is 99. So we sold 99 child tickets that day. They don't want you to go back and find out how many adult tickets they sold. All they want to know is child tickets. So make sure you're paying attention. What are they asking me? And in this case, I had to set up the two equations in order to get the correct answer. So it's a little different on this one. The box didn't fully work, but it worked for, most of it. It was just that bottom piece here for the tickets and the cost. That was a little different. All right, so that was our first experience with mixture problems. Go ahead and go on, Alex, and give that a try.